Namaste everyone. Hope all of you are well. Stay at home, stay safe. The most important terms for this 2020 is stay at home and stay safe. If you will be alive, then you can learn everything, you can understand everything, and you can do everything. Okay, let's come to the topic. Actually, some of the students were having a lot of curiosity about. So, what's about the valence bond theory? After the valence bond theory, which theory was produced and how many theories are total there, especially for the bonding, chemical bonding? So students were having a lot of curiosity. Now generations, we can't just say, yeah beta, there are a lot of theories, we have to study only this theory. So if you are having a curiosity, then don't worry, I will solve your all the curiosity whatever you are having. So first of all, for my 11th standard student and 12th standard students are having a lot of curiosity. So first of all, we have learned about the Lewis dot theory. After that, you have taught about Vosper theory, valence and electron pair repulsion theory. Then you have taught about the valence bond theory. Is there any more theory? So first of all, let me say you, yes, there are two more theories. That is CFT, crystal field theory, and LFT, ligand field theory. If you are a student of any competitive examination, just like IIT JEE, NEET, or the advanced level examinations, so for that you must have little knowledge about it. Since this is a course of BSc and MSc, but then also some of the students are having a lot of curiosity to understand this topic. So don't worry, I am there. Today I will teach you the topic except of Vosper theory and valence bond theory. Today I am going to teach you crystal field theory. First of all, what is crystal field theory? Who have given this concept? Each and everything I have written on this board, you can just see here. The crystal field theory was specially given by Bethe and Van Vleck, and this theory is 100% for ionic compounds. The students were having a lot of confusion. So, can you tell me that is there any compound 100% ionic, or is there any theory which can deal that 100% ionic compound is there? Because I have taught them percentage ionic character, so that time students were confused that they were, sir, there is no compound which is having 100% ionic character, or no covalent compound which is having 100% covalent character. Yes, you are right, but if you come to the, still yet you have learned only the S block and P block elements, covalent compounds or ionic compounds. Now let's come for the d orbital compounds or complex compounds. Then you will understand, is there any compound which is having 100% ionic character, or any of the scientists have given this theory that really any compound can have 100% ionic character. So this theory is specially for ionic compounds, 100% ionic compounds. So that's why you can see here, crystal field theory basically concerned with the interaction of d orbital. As I have told you, we have just learned about the S block and P block. This theory is basically concerned with the interaction of d orbital of the central metal atom or ion with the surrounding ligands and produce crystal field effects. So now we are not going to discuss about the S block and P block combination, or P block and P block combination. Now we are coming to the main points, as we have read in the 12th standard about the coordination complex. In the coordination complex, you may have just gone through about the hybridizations and the magnetic properties, just like magnetic moment. But here something new. So let's go through the postulates of crystal field theory. Here I have written only 7 postulates. More I will write. But first let us discuss about the 7 postulates of crystal field theory. The first postulate: the central metal atom or ion and ligands as a point charge, and the interaction between them is purely electrostatic. According to crystal field theory, the metal ligands bonds are 100% ionic. The student had asked me, he or she was in 11th standard, so is there any compound which is 100% ionic character? Is there? Then I want to tell you, yes, my dear student, definitely. There are compounds which are having 100% ionic character. As I have told you, that is crystal field theory is basically concerned with the interaction of d orbital. So you must have a knowledge of coordination complex, then only you will be able to understand. So this central metal atom or ion is surrounded by the ligands and produce crystal field effect. The first postulate was that the central metal atom and ion ligands act as a point charge. Ligand act as a point charge. Here there is a ligand in the metal and ligands. Just suppose that if I talk about any central metal iron or any ligand cyanide, so here crystal field theory, that central metal atom ion and ligand act as a point charge, and the interaction between them is purely electrostatic. Interaction between them is purely electrostatic. According to crystal field theory, the metal ligands bonds are 100% ionic. Got it? Now the second postulate, there is no interaction between the metal orbitals and ligand orbitals. In the coordination complex, you may have heard about in the valence bond theory also that there is an interaction between the metal and ligand orbitals. But if I talk about the crystal field theory, so there is no interaction between the metal orbitals and ligand orbitals. So this is the difference between the CFT and VVT. Crystal field theory and valence bond theory, if they will ask you what is the main difference, so here you can see there is no interaction between the metal orbitals and the ligand orbitals. That is the main important point. Third point, the d orbital on the metal which were of the same energy. The d orbital on the metal which were on the same energy, that is degenerate in a free atom, have their degeneracy destroyed by the ligands where a complex is formed. What does it mean? It means that here first of all understand the d orbitals, each and every orbitals are having same energy, so the degeneracy, as the degenerate in a free atom, if any atoms d orbitals, degeneracy or each and every orientation have a same energy, now you just suppose as this degeneracy is destroyed means now the energy level is varied. Each and every orbital orientation is not having the same energy now, as it is being destroyed. Why it is being destroyed? Because of the ligands, and then only there is the formation of complex. Means all the 5 degeneracy of the d orbital free atom when come in the context of the complexes, then this degeneracy is destroyed. This degeneracy is destroyed and a complex is formed. Next point, if I talk about, a complex is considered to be a combination of central metal atom ion surrounded by the various ligands. Definitely if a compound is formed, then definitely there will be a central metal atom or ion and it will be surrounded by the ligands, right? It will be surrounded by the ligands. Now if I talk about the ligands which is interacted with the central metal atom or ion, the ligands in the complexes to be considered, either they will be negatively charged, either they will be positively charged, or they will be neutral charged. So here negatively charged and neutral charged, some of the atoms or ions I have written as fluoride, chloride, cyanide, ammonia and water, which are neutral molecules which has a dipole such that the negative end is closest to the central metal or ion. Remember this word, it is the negatively positive charge or neutral which are having a dipole moment which is nearer to the central metal atom or ion. The interaction between the central metal atom or ion and ligand in a complex regarded as a purely electrostatic when they are attracted by the electrostatic, purely electrostatic. Since I already have told you it is 100% ionic, then definitely they will be a purely electrostatic. So the attraction between the metal and ligand, central metal atom ion or ligand in a complex is purely electrostatic. Now the 7th point, if I talk about the interaction between the electrons of the cation and those of the ligand is purely repulsive. The repulsive forces are responsible for causing the splitting of d orbital of the metal ion into the groups. Now remember this word, this is the main important point for crystal field theory, that why d orbitals split into the 2 parts, that is T2G and EG, axial and non-axial. So here the interaction between the electrons, of the cation means metal, and those of the ligands which are anion are purely repulsive. It is not attractive, it is not combining, it is not constructive, it is repulsive. Because of the purely repulsive forces that is a cause of the splitting of d orbital into the two parts, that is T2g and EG. T2g means axial and EG means non-axial. If anybody will ask you what are the axial orbitals and what are the non-axial, so dxy, dyz, dxz are the axial orbitals, and the non-axial, if I talk about the axial and non-axial, sorry, if I talk about the axial and non-axial, then dxy, dyz, dxz are the non-axial, and dxy square z square and dz square are the axial, which the dx square y square and dz square take participate in the bonding. So let's go ahead. After the 7th point, there are few more points which I am writing on the board. Just take a screenshot, that it is more beneficial for the students which are doing the preparation of any competitive examination. Now see the rest of the postulates as after the 7th postulate. The main postulates begins from here of the crystal field splitting theory. The orientation of d orbital. All of us know that there are 5 orientation on the d orbital: dxy, dyz, dxz, dx square, y square and dz square. These are divided into the two parts, non-axial and axial. Means non-axial means what? You can see here these orbitals orientations are not on the axial. You can see here this is the x, this is y axis. They are between this. They are not on the axial. So that's why they are known as non-axial. D x axis, y axis. So here this is known as dxy, y axis and z axis. This is known as yz, and z and x, this is known as zx. So here you can see dxy, dyz and dxz, and rest two, dx square, y square and dz square. These are also known as triply degenerate. What are these known as? Triply degenerate. So here you can see non-axial, they are also known as T2g. What they are known as? T2g. They are triply degenerate, and these two, dx square, y square and dz square, these are axial, these are EG, and they are known as doubly degenerate. What are they known as? Doubly degenerate. So this was the 8th postulate. Now let's come to the splitting of d orbital depends upon the geometry of the complex. Yes, now the question is very nice, that which type of splitting of d orbital will be happen in the axial, non-axial, where it will go. It depends upon the geometry of the complexes. It depends upon the geometry of the complexes. Let's read the 9th postulate. The 9th postulate is the electrons of the metal ion. The electrons of the metal ion are repelled by the negatively field of the ligand, and therefore the metal electrons will occupy those d orbital which have their lobes farthest away from the direction of the ligand. Remember, these are called the lobes, positive lobes and negative lobes. In the axial you can see one will be positive, one will be negative, one will be positive, another will be negative. As you know very well, in the p orbital only you have seen pxy, right? So both the sides, this lobe dumbbells, lobes, these are called lobes. These are called lobes. Okay, so in both the lobes, as the metal and ligand, see here as I have written also, therefore the metal electrons will occupy those d orbitals which have the farthest away their lobes. Means as the lobes will be farthest away, then there will be no interactions. Means they will be repulsive, as here are written, which have their lobes farthest away from the direction of the ligands. Directions of the ligand to the metal lobes will be the farthest away. The number of ligands and their arrangement around the central metal ion will determine the crystal field ion. Means which type of crystal field ion is that? It will be depending upon the number of ligands and the central metal atom or ion. The central metal atom or ion only give us the information about the ligands, how they are interacted and which type of complex is that. Next, in this theory, the covalent character has not predicted into the account. Means the covalent character, the bond between the metal and ligand has not taken into the account. Means this theory does not deal a single percent covalent character. This crystal field theory is especially for the ionic characters, as already I have told you. Now, as I have told you about, this theory does not permit the electrons. Yes, very very important point. Remember these important points, dear students. This theory does not consider orbital overlap. As I have told you, since it is not a covalent character, so this theory does not consider any orbital overlap. Orbital overlap means covalent character. Since this is not considering a single covalent character, means there will be no orbital overlap. This theory does not permit the electrons to enter into the metal orbital. Crystal field theory does not permit, it is not giving the permission to the electrons to enter into the metal orbital, right? The next one is the splitting of the d orbitals into the sets under the influence of approaching the ligands having the different energies is called crystal field splitting energy, CFSE. The symbol is delta. Delta, you know very well, triangle shape. So here the main important point, it starts from here. The splitting of d orbitals into the two sets, approaching the ligands. As the ligands will approach to the central metal atom or ion, they will have different energies, that is called CFSE, crystal field splitting energy, and it is represented by delta. So here now you can see the crystal field splitting energy is frequently measured in the terms of parameter called dq. What is called dq, which is an arbitrary set of 10 dq. Total d orbitals are having 10 dq's energy. So each, that's why 2 dq for each unpaired electron. Since already I have told you there will be no pairing, no covalent character, so 1 unpaired electrons. Each unpaired electrons will have the energies of 2 dq. You can see here, this is the degenerate d orbital in the ground state, this degenerate d orbital in the excited state, and how they has been splitted: dxy, dyz, dxz, dx square, y square, dz square. The total value is 10 dq. The total value of this 5 orientation is 10 dq, each having 2 dq. So dxy, dyz, dxz, upper side is positive, so that's why it's called plus 6 dq, and negative is minus 4 dq. So the total is 10 dq. As you can know about the crystal field splitting parameter, the crystal field splitting energy delta is frequently measured in the terms of an arbitrary set of 10 dq, that is 2 dq for each unpaired electrons. You can see in this diagram, as I have represented here, in this diagram it's easily cleared. The difference of energy between the two levels is called crystal field splitting parameters. You can see the barycenter. The energy associated, you can see this crystal field splitting parameters, energy difference, dxy, dyz, dxz, dx square, y square, dz square, that is total 10 dq, and this between that is called barycenter. What it is called? Barycenter. So here you can see the values. The energy associated with the lowest split orbital is called crystal field stabilization energy. Lowest field is called crystal field stabilization energy. The energy associated with the ground term is called crystal field stabilization energy. In the ground term it is called stabilization energy, crystal field stabilization energy. On the basis of the value of crystal field stabilization energy, the stability of the complexes can be predicted, as well as the spinal structure of the mixed oxide can be explained, whether the mixed oxides are normal spinel or inverted spinel. In the normal spinel and the inverted spinel, as this both will go down and this energy will rise again. So in this whole crystal field splitting energy, you must remember what are the postulates of crystal field theory. What is crystal field theory? What are the 15 postulates of crystal field theory? I hope that this is a very important thing, but it is not for the 10th and 11th or 12th standard student. It is for the higher students which are prepared. But if you are interested to any competitive examination like JE Advanced in India, SET examinations for the 12th level or any scholarship test examination, then you must go through this video. I hope this video will clear your concept about the crystal field splitting energy, how the d orbital split, and what are the energies, what are the parameters, what are the stabilization energy, CFSE, crystal field splitting energy, crystal field stabilization energy, the lower energy and the higher energy. Hope all of you have understand about this video. If you are having any doubt related to this video, then please drop it out into the comment box section. Definitely I will help you. Whatever your doubt will be clear. Whatever your doubt is there, I will clear all the doubts. Don't worry about the doubts. Just drop it out into the comment box section. Hope all of you have enjoyed. If you have enjoyed this video, if you understand the concept, don't forget to like and subscribe the channel. Share this video with your friends so they can be also benefited. That's all. Thank you. Take a screenshot.